I purchased this Pacman 2 handheld game from eBay. Purchased it for £20 plus about £3 postage. It was listed as spares or repairs. It had some fault. There was no pictures of it actually working, so whatever the fault was, I assumed that it was some sort of power fault or something else that was stopping it working completely. In my head, I thought maybe transistors. It seemed to be a similar age to sort of the handhelds like Firefox and Scramble and Astro Wars, those sort of machines. I know Astro Wars in particular. There's a transistor or there's a diode that usually fails in those, so that was where my focus was going to be. The picture showed the battery terminals being quite clean, and when I opened it up, they were clean. They were a little bit tarnished, but certainly didn't look like it had any bad battery leakage. The instructions on the bottom were nice and clear, and overall it was in fairly decent condition. This thing wanted 4 C-size style batteries, again very very similar to those over style games. They all seem to take these 4 C-style batteries. So I've tested the batteries because I haven't used them for ages, but they all tested good, and I've put them in the machine. I've checked the instructions online, and there's a sound switch that goes from mute to off to sound, and when it's in the off position the machine is off. So to turn it on you just need to switch that sound switch either to mute or sound. But no matter what I did with the switches, I didn't get any life out of it at all, which matched the description. The first thing I wanted to try is do I get potentially 6 volts out of these batteries. So I wanted to test it from sort of plate to plate, so just working out which way round they are. But once I figured out where the start is and where it ends, I should be able to see 6 volts across these batteries. Got 3 volts across those two. And 3 volts across those two. And I'm testing on the pads as well, so that the connection between the batteries and the pads seems to be quite good. And there's my 6 volts. So pad to pad, in that way I've definitely got 6 volts. So the battery connections, at least to the pads, are good. So I think it's time to open this up and have a look inside it and see what we can see inside. Removing the batteries reveals 4 screws. Couldn't see any other screws, so hopefully it's just a question of taking these screws out to get access. I had a look at a few screenshots when I brought it, and it seemed to be quite a nice game. Quite a bit of detail in the maze. It wasn't just a tiny playfield, it was quite a decent playfield, it looked like. Some nice and bright sort of graphics. So opening it up, splits into 2 batteries on one side with a power connector, and on the other side you've got 2 little boards that manage the controls. They're connected via some ribbons to the main board, and everything's just you've got a speaker as well over there, and then everything is off of that that main board. You've got the chip on the back, but everything else looks to be on the same side as what the screen is. So I'm just checking I've still got my 6 volts across the batteries. And I'm checking at the main board as well. So I can see I've got 6 volts going into the main board. So I'm definitely getting power from the batteries to the main board. Just going to remove the power board now, because I want to take this main board out and have a better look on the other side, see if I can see anything obvious. It's going to be a lot easier to work without these power cables connected. So just desoldering them. They can get that out of the way and focus on the main board. So you've got 2 screws on each control board and 4 screws to undo on the main board. Just want to be careful with these ribbon connectors. Don't really want to break them. I mean, they are repairable. You can just run individual wires between the boards, but it's just sort of a pain that you don't really want to deal with. Speaker just lifts out, wasn't connected in any way. And I can flip this over and have a look at what's on the other side. So it's not a huge amount. Most of it is taken up by the massive screen. There's a couple of transistors, which obviously, you know, based on what I said earlier and in my head, that they're going to be suspect. We got a couple of capacitors, but there's not a huge amount on there. Quite a few diodes as well. But looking at the back of the board, I can't see any obvious signs of damage. I can't see any broken traces. I can't see any dry joints. Everything looks good on the back of the board. So this diode was a bit suspect because it was passing current both ways. When a diode isn't going to do that. Now obviously I'm testing everything in the circuit here, but I've made a note of D04, and the plan is to take that out, and I'll have a look at that out of circuit in a bit. Just checking all these diodes over here. See, they behave like I would expect a diode to behave. So in a diode, in multimeters on diode test, one way don't get anything, and the other way you get about 0.5, 0.6 volts. I keep going back to D04 and getting the same result. So definitely going to have a look at that. So the plan is, let's take out D04, let's take out the 2 transistors, and let's give them a test. So I'm just going to use the hot air gun to try and remove these transistors. They're fairly close to each other. They are marked up just on the board as to which is the base, which is the collector, which is the emitter. But I'm also going to take some pictures just on the orientation, just to cover myself and be sure. So that's one removed. I'm just putting it into the tester. Put a probe on each leg. Turn it on, and it should tell me, I mean, so I don't know the spec of this transistor, but it should tell me what type of transistor it is, and it should tell me if it's working, which it is. Now, as I said, I've got no reference to know if those values are correct, but at least it is detecting it as an NPN transistor. So I think the transistor's good. So I'm just going to remove the other transistor and give that a test. Just noticed that there are actually 2 slots for this transistor. So I was trying to work out which one it actually came out of. Not sure why the board's got that design, but yeah, 2 rows of 3 next to each other. So same again, 1 leg on each. This transistor is a slightly larger transistor, so they're not both the same. And again, I don't know what the specs of it are. So this one reads also as an NPN transistor. So potentially both transistors are good. And just to be doubly sure, I thought I'd also measure it with the multimeter as well. So the multimeter is in diode mode, and I'm just checking it with the multimeter just to make sure that the one way across the legs I'm getting nothing, and the other way I'm getting that 0.6, basically two diodes in there. And I do, so it passes both tests. So odds are these transistors are good, and I've got some of a fault. So I'm just going to solder the transistors back in. Now I've ruled them out. Might as well get them back in so they don't get lost, don't fly across the desk. And I can move my attention to that diode that I didn't like the look of as well. That D04 diode. Right, back to the soldering gun. Let's get that diode out and test it out of circuit. Just being careful with the diode. Any pressure that I put on it, I'm making sure that I put pressure on the leg rather than actually the diode itself. The diodes, especially if they've been hot and got hot, they can be quite brittle. So just making sure that I'm only putting pressure on the legs. And again, just taking a picture to make sure that I've got the orientation right. The markings on them are quite faint, so just want to make sure that if it's okay and I do put it back in, that I can put it back in the right way. Been a bit stubborn to come out, so just giving it a bit more heat while I apply pressure to the leg with the screwdriver. Hopefully that's going to be enough to get it out. But again, just being really careful because I don't have any reference. If I did break the diode, I may struggle to figure out what it is. So using the tester, it detects it as a diode. Just testing it again. But yeah, it detects it as a diode. So potentially it's not faulty. I mean, as I said, it was passing current one way, and it seemed to be passing a different amount the other way. But I'm just going to do the same test now. Now it's out of circuit. Same test with the multimeter. So one way I can see it passing current, and the other way, out of circuit, it's now not passing current. So out of circuit, this tests as a good diode. So it's not the diode either. So the next plan is to break out the bench power supply. So this is one that I've made, 3D printed case, internals, the main part of it you buy from AliExpress, powered by either USB or in this case I'm using a laptop power supply. I've set it at 6.1 volts. And you can't see because it's off the screen, but I've also limited the current to half an amp as well, because I didn't want it to kill anything. But if you noticed, it was on, and the telling thing here is that it's drawing 0 amps. It is not drawing anything. So what I was thinking is I'll put this thing on, I'd see it drawing some current, and potentially something's going to be getting hot, to show maybe it's gone short circuit, but it's drawing nothing. So there is no power getting to anything. So the attention now has to go to the switches, because there's a break. There is a break somewhere. So I guess going back to that theory that if these things don't get dropped, if obviously you don't know the history of them, but if something hasn't been plugged in incorrectly, like someone's used the wrong polarity power supply or just the wrong voltage power supply, then failures tend to be either points of wear, so where someone's plugging something in and out all the time, or it could be, in the case of a switch, where the switch has been sat in one position. It could just be that it needs a really good clean. So did a few tests and just chasing around the voltage, trying to see how far I could get. I could chase the voltage up to some of the switches and it stayed at around 6 volts, but on the switch that actually turns it off, the one that has the the sound controller, then coming out of that, the voltage seemed to drop to about 4.5 volts. So this switch here, this is the 1 player, 2 player switch, but all around here I'm getting this 5.6 volts. Again, same for the middle switch, bit less, but again still up in the 5 volts. when I hit this switch, I'm getting 4.7, 4.6, 4.5, and also it's dropping away as well. So that's the switch I'm going to focus on. I need to clean the switch. I'm going to put some deoxit in it, work it, and but while I do it, I might as well do all 3 switches at the same time. So I've disconnected it from the power. And on 2 of the switches there's a couple of holes on the side, so I'm going to try and get the deoxit into that. And on the middle switch where there's no hole, I'm going to take the sort of the black protector off and just try and squirt it into the top of it. Switch was quite stiff, but like anything switch, variable resistor, once you put the deoxit in, the idea is to work the resistor, work the switch backwards and forwards, and as you're doing so, it's sort of creating its own abrasion, and the combination of that and the combination of the deoxit is breaking up that oxidization. Potentially I could disassemble the switch and give it a more thorough cleaning. That might be possible, or worst case I may need to desolder the switch altogether and replace it with a replacement if I can find one. But first stage is just spray some cleaner in it. Let's see if that sorts it out. That's been done. Let's hook it back up to bench power supply and see if that's made any difference at all. Am I now seeing a current draw? Do I get any life out of it at all? As soon as I turn it on, something on the screen. That's me turning it on and off with the bench power supply. Just wanted to make sure everything's okay. And we've got sound as well. Just using the tweezers. I think I need to turn them around. It's not going to work that way. Just to try and short those pads. There we go. You can just see it. Pacman starting to move. So as I short the pads, Pacman's moving around the maze. So this is looking promising. From a completely dead machine, we've now got signs of life. So cleaning up the pads while I'm in it, I might as well. Just give them a very light rub with cotton bud and isopropyl alcohol, and I'll just clean the screen as well, give it a wipe while I'm in here, and then I'll close it up and give it a test. So that's it reassembled. Power connectors all reconnected. Batteries are still in. Oh, it doesn't work. We just had it working. So why is it not working now? Ah, there you go. If I push down on the switch, we get some sort of life out of it. So the switch still isn't right. Notice that the ground wires come away from the main board, so I need to fix that. But the fact that I got it, I mean, it could be the ground wire not having a good connection. But let's get it reconnected and try it again. Okay, that's it hooked back up, and it's still got the same issue. Yeah, that's not good. Right, I need to take it apart and give that switch another go. I'll try and clean it again first, a bit more rigorously, and then if that doesn't work, think about the other options about what I can do with this switch. Let's take it apart again. Just removing the little plastic cover from there as well, and I'll put that with the other one that I forgot to put back the last time I put it back together. I'm going to hit it from the top as well as the side, and just really give it a really good soak in. Just completely soak it, work it again backwards and forwards loads of times, and then test it again. Okay, so that's it connected back up to battery power. This time it works. It works a lot more consistently. Still not 100%, but it's actually not bad. I would say the switch is about 95%. And as I start to use it more, it starts to improve as well. Remember to put these plastic covers back on this time. They just stop dirt getting into the switches. They just slide over the red switch. Bit of a tight fit, they do go on. Right, that's everything back together. Just gonna leave the screws off for this minute. Let's see if that's an improvement over last time. Switch is a bit stiff. Works on mute and it works on sound. So, I thought, right, let's give it a go. And I was just focused on the controls and how responsive they were. When I noticed that the ghost wasn't really doing a lot, it sort of just sat there stuck. So I thought, oh, I've got another issue. I've got a problem with the chip where the chip's drawing the ghost but it's not moving it. But I thought, is this a really easy introductory level where you just get to play the first level and the ghost just sits there watching you? Maybe I eat a power pill. Maybe that'll wake the ghost up. The ghost starts flashing, but he's not moving. So I played it all the way to the end of the level, thinking maybe level 2 will kick it into life, but it didn't. Let me just cut to that bit. Yeah, ghost is still there in his home, not moving. So I thought, is it a skill setting? And then I noticed it was set to 2-player. So I thought, okay, let's try 1-player. See if that makes a difference. And this time on 1-player, we got multiple ghosts, and they're all coming after me. So it was 2-player. Now, when I saw 2-player originally, I thought, it must be like a cocktail cabinet where you each take your turn. But I started then triggering that maybe 2-player controls the ghost. So player 1, in 2-player game, player 1 is Pacman and player 2 is the ghost. That's quite a cool twist. I've never seen that before. But the switches seems to be working a lot better now. And this is me playing it on 1-player mode with the ghosts alive and after alive it goes. Yeah, that's funny. The ghosts are what state are ghosts in? Anyway, they're moving and they're coming after me. So result in the end, very pleased with how much I paid for it, very pleased with the condition of it, and very happy that I was able to fix it. We'll see how long the switches last, but for now I'm going to enjoy the game. Thank you for watching.